Okay, so it is 10:20 and 7:04 in the morning. And we look here at 10:20 read void methods. So your your first exam is going to be open next class, and then it'll be open for a period of uh, a good amount of time, probably 48 hours, to give everyone a chance to take it. So it won't be with ProctorU because ProctorU um, doesn't work with MDC Live. So it's no big deal. But I'll have the link, and then you can just take it next time. So today we're going to be looking at read void methods. So we look here at void methods. Now the truth is that you've you've seen you've seen void methods before, right? Um, this is going to be an interesting day because we can look at some pretty cool stuff, right? So let's go ahead and let's start with the top, which is going to be the math methods. So let's go to Java math functions, and here's the API, and we can see the class math contains methods for performing basic numeric operations such as the elementary exponential logarithm, square root, and trigonometric functions. Unlike some of the numeric methods of class strict math, all implementations, let's see, I think someone's accidentally unmuted. Yeah, let's see. Okay, so unlike some of the numeric methods of the class strict math, all implementations of the equivalent functions of class math are not defined to return the bit-for-bit same result. This relaxation permits better performing implementations where strict reproducibility is not required. By default, many of the math methods simply call the equivalent method in strict math for their implementation. Code generators are encouraged to use platform-specific native libraries or microprocessor instructions where available to provide higher performance implementations of the math methods. Such higher performance implementations still must conform to the specification for math. So if we just scroll down a little bit, we can start seeing the different fields, okay, and the different methods. So we have absolute value, we have the arcsine, arctangent, the ceiling. I think ceiling was used in our last programming example, right? Like, didn't I use ceiling in the Code Wars example? I'm pretty sure I did, yeah. So a lot of these are very useful because then you don't have to write your own. You know? That's the point. So if we were to look up Java source code math.ceiling, math.ceil, we can see, okay, this is the source for java.lang.math. And we can scroll down here and see final class math. And you can see like how they type everything in. So this is how they type some of the fields. But we're getting to ceiling. Now, scrolling down, you see absolute value, right? That's not hard to program. You say, okay, if something is less than 0, then, okay, if something is less than 0, then send it negative, and then that would just take something negative and then make it positive. Otherwise, just keep it what it is. All right, so let's get down to what we said we're looking for. So let's do a search for ceiling. And there it is. Okay, so for ceiling, it calls VM math. Interesting. Okay. Let's see. So I guess we have to look up VM math. But that's not too bad, I don't think. Let's see if we can find it. VM math, Java source code. All right, so here it looks like someone put it on GitHub. And we can see we're looking for ceiling. Okay. All right, it says static native double seal. Take the nearest integer that is greater than or equal to the argument. If the argument is not a number, infinite or 0, the result is the same. If the argument is between -1 and 0, the result is -0. And it says note that the math ceiling equals the negative floor, -x. And then we just see this static native double seal. So native means in Java native keyword. All right. Java native means you are going to call a dynamically loaded library and get results back into Java. So it could be written in a different language like C, right? That's probably what it's written in, C. So the reason is because you can write faster code with better CPU assembly instructions. So keyword native in Java allows you to write code in another language, like C, for instance. So we sort of were on a little bit of a scavenger hunt of our own this morning, just thinking about the ceiling method. We couldn't possibly do that with all the math methods because there's just so many of them, right? So just as with mathematical functions, Java methods can be composed. This means you can use one expression as part of another. So you can have x equals the cosine, math cosine, angle plus math.pi divided by 2. All right, and then of course you can add new methods. You don't have to just use methods created by others. And now we get to the flow of execution. So we've got public static void new line, public static void 3 line. Remember, with static, you don't need an object to run them. So down here, we can just call 3 line, and it's just going to print out new line, new line, new line, right? Okay. Now this is important to talk about this vocabulary. Parameters and arguments, okay? Parameters are when you set the method up, like string s is a parameter. When you send in, don't make me say this twice, that's the argument, okay? So the argument is the data you're sending in. The parameter is the structure that you've set up for the method. Multiple parameters. Here's an example of a method that takes 2 parameters. So it takes in an integer and it takes in another integer. In the parameter list, it may be tempting to write int hour and minute, but you can't do that. You always have to say the data type. Now, stack diagrams are kind of interesting and they're worth talking about. This is going to be how you're going to call all the methods, right? So we have here a main method that's going to set up hour, minute, and then call print time. So if we look at our stack diagram, we see main, we have hour and minute. And then in print time, we are going to have an hour and a minute, right? So the stack refers to memory. Because basically that's all we're doing when we're programming, right? We're managing these discrete pieces of data in memory. But we're doing it with variables that we know how we can access. So we know what the hour is because we know the name of the variable. We know what the minute is because we know the name of the variable. And that's inside main. Now inside print time, where the scope is different, there's an hour and there's a minute. So Java is copy by value. Any changes to the hour and minute inside of print time are going to be different. Okay? This is showing that the hour is different because you do some kind of manipulation when you send in the hour. All right, and then documentation. Hopefully throughout this class I've always emphasized you need to look up the documentation. You need to look up the documentation. That's the only way you're going to manage working with Java. To just go through and look for the different things here in the Java API. Right? So I think that's a 15 minutes of straight talking from me. Maybe a little less because I think we started at 7:03, but still pretty good amount of time of me talking. And let's jump into some coding examples now. Let's do some coding examples. So can anyone think of an exercise we could do with math? Right? Can anyone think of an exercise we could do with math? So it could involve any number of different mathematical functions or exercises. Oh, an exponential growth exercise. That's awesome. I love that idea. That's really good. Hey, I like that. So let's go ahead to Replit, and we'll go here to create REPL, and we'll say Java. We'll call this exponential growth. And we can go ahead in here and we can have a method inside class main. Let's just keep class main toward the top. So we'll make a static method, method to illustrate exponential growth, and we'll take in a base rate, and a growth rate, and then we'll also have a period of time, right? Growth rate per year, and then we'll have period of years. That sounds good. Okay, so we'll make this static so we can call it without having an object. So we can say public static void. So we'll just continue with the void methods. We're not really returning the number, we'll just print it out. Public static void exponential growth. And so we'll send in int the base and then int growth. Well, actually, let's make these doubles. That makes more sense. Double base, double growth, and double period. Okay. And the period's going to be in years. So period of years, let's make life easier and just do that in int. Because we're just sort of...
Can you do it instead of making it a method? Can you make it like a class so we can add number?
Yeah, we can make this into a class. Sure. But methods you can...
practice a little bit the class thing.
Sure. So you want to make a class exponential growth. And then we have here double base, double growth, and int period. And then we can say here public exponential growth, double base, double growth, int period. So we've now got the start of our constructor. Constructors have the same name as the class, but they don't have a return type. Here the return type was void with exp growth inside class main, but here inside of our class we have a no return type for the constructor. And you'll also notice that when I'm making my classes, I'm putting them outside of the other classes. We haven't done anything with inner classes, right? If I was to put this class inside of this class, yeah, inner classes are legal, but we haven't really discussed how to access them, and we haven't discussed why we would use them. So this is a mistake. Students will sometimes send me code where they're putting the classes inside of the other classes, but that's not what we're doing with these different classes, right? Like we're just making other classes with their constructors all standing on their own. They're not requiring other classes. They're not inner classes. And I think this is just a super important thing to say explicitly, just so you keep in your mind, okay, whenever I'm making a class, I'm outside of another class. I've got my curly brace that starts and my curly brace that ends, all away from other classes. Not that it's a big deal to do inner classes, it's not, but it's just not something we're doing right now. You know, learning has to be sequential. Learning has to have some sort of starting point. You can't do every single thing at once, or else it just becomes too overwhelming. Okay, so now we have to keep our data. So we say this dot base equals base, and then this dot growth equals growth, and then this dot period equals period. Okay, so at this point right now we have the data. This is our constructor, and these are our fields or attributes. And then we can just go here, post this in Discord. Now we're going to want to make our growth method. So we'll say here, I guess since we're making a class, well, I mean, we'll just make it static again. It doesn't matter. So we can say public static. Well, no, let's just make it a regular method. Public void, and we'll call this one calc growth. And now we can say inside of here, we can say we're going to loop through the number of periods. So we'll say for int I equals 0, while I is less than period, I plus plus. And we'll say a little print statement, system.out.println, with the base grows at growth per year for, and then we'll put period years. That sounds good. And then we'll put double, we'll say base equals math dot cow, right? And we're taking the base to the growth, and I don't know, I don't take them out. I didn't take them out. So let's see. So we have the base equals the math.pow base growth. And let's see if this does it. So at the end, system.out.println base, let's say. So we'll think about some kind of example here. And I don't know if this works yet, right? I haven't tested this. So I'll say first iteration of coding is like this. And now we can call calc growth inside here. So we can just make the object. So we're going to say, we're going to call this class exp growth, and we'll just call it bunnies equals new exp growth. And so let's say we start off with 2 bunnies, and the growth, what is the growth rate for bunnies? So bunny reproduction rate per year. Oh my God, they can really have 7 litters per year? That's insane. Okay, so let's just go in the middle, 3, and then we'll say they have 6 babies each time. So, man, boy, it's just getting complicated. So, let's see. Gosh, how do we model this? Bunny growth rate, let's look that up. Bunny growth rate per year. Let's see. Population growth problem. Rabbits were introduced in Australia. See, it gets complicated. I'm just looking for like a standard. I don't know. I mean, this is a big growth rate because they have so many litters. So I don't know. Let's say that if these 2 bunnies can have 6 litters of 6, I mean it's growing at a really high rate. I mean, how to calculate growth rate? Let's see. So it is the current population minus the previous over 100. So if it goes from 36 minus 2 over the original, I mean, I was 99% sure. So it's growing at 17 times. So it's growing at 17 times, 2, so we can go back here to Wolfram, 2 to the x equals 17. All right, so if it was 16, it'd be a little easier to model because 2 to the third is 16. No, 2 to the third is 8, not 16. So 2, 3.5, that's getting closer. 2 to the fourth is 16. So we can say something like 2 to the 4.3, 4.2, 4.1. Oops, that's not it. 4.1. Yeah, that's pretty close. So we can do 4.1 is the exponential growth rate, so 4.1. And the period, let's just say like we're going to have 3 years of bunnies going, and then we'll run this calc growth. So we'll say bunny dot calc growth, and let's run it and see if we get some reasonable numbers. And no, that's, oh my God, that 5.5 to the 20th, right? Like that's ridiculous. So if we printed it out each time, we could see system.out.println base. Let's see. Yeah, so we start off with the first year they get to 17, and then the next year they get to 114,000 bunnies, and then the year after that, see, it's assuming this is assuming that all the growth rate continues and all the bunnies are making lots of new bunnies in the next period, which does happen, right? Like little baby bunnies grow up and then they start reproducing. The thing is, we're not dealing with any sort of death here. We're not killing off any bunnies. Bunnies get eaten by wolves, and I mean all kinds of animals eat bunnies, right? So this is a really interesting problem, and it does show how exponential growth can just lead to insane numbers, just really, really insane numbers. So I like those sort of questions and problems. This is my first attempt at just modeling some exponential growth. I definitely know that mathematicians could add so much interesting stuff to this question, right? And that might be kind of a cool thing in the future, like if math instructors and programming instructors would have days where they come together and then like they can talk about certain assumptions you make when you're modeling, and programmers can sort of do some of the implementation. I think that might be like a fun thing. And you know what we can do? We can just look up online. We can say Java population modeling software. Like, let's just look this up. All right, let's see. It says world population growth in Java. Oh, this is just somebody did homework. So it says here, they've got the population, they've got the growth rate, and then this is how they modeled it. They didn't use a class or any static methods. They just did everything inside the main, which is fine, right? So they're taking the population times the growth rate. I wonder if this is a bad assumption, like sending it to, let's see. Rabbit population growth exponential. Rabbit population exponential growth. Let's see. I like this, a textbook. This is good. So it says here, when a species is introduced to a new environment, it has no natural predators. This is what we were trying to model. It multiplies quickly. This happened in Australia when this guy released 24 rabbits for hunting. Yeah, this is the geometric sequence starting with term 24 in a constant ratio. All right, so let's see here. An explicit formula for this sequence is, okay, so they started with 24, right? They started with 24 times 3.5. Okay, so I think our equation needs to do something a little bit differently. I think instead of putting this, here to like this, I think we need to multiply the base times, I do think we need the loop. 4 int I equals 0. Or do we need the loop? Um, let's see. So this is the formula the textbook gives us. So this is the formula the textbook gives us. Okay, so this will be fun. I can get some input from you guys as to what you think we should be typing out here, right? So this is how they model the bunny population. So help me out. Help me turn that into Java code. So we're saying I mean, I guess I could just type it out as they have it, right? I mean, I'll just type it out the way they have it. So I'll say return, which is good. I mean, like they have a more reasonable guess because they've studied this a little more. So I can just return the base, and we'll just take it to, no, we'll do base times the growth rate, to the period, and then we can run this. So they give the example of 24, and they say for, let's see, they say for 4 years, you're going to get around 2,600. So we'll say 4 years, and the growth rate is 3.5. So 4 years, and our growth rate estimate wasn't too far off. All right, let's see if this gives us around that number. All right, 3601, and theirs is at, no, ours is too high, it looks like, because they're at 4 years, 2,600, and we seem to be getting a little bit higher. Let's try 2 years and see what happens. 2 years. So 2 years down here. 2 years is 294. So ours is just a little high because theirs is coming in at around 200. Let's see. Oh, okay. So the graph at the left, it shows. Yeah, I'm not quite sure what the different graphs are showing. Oh, this one. Yes, yes, yes. This is the one that we just modeled. Okay. So 2 years, 294, 4 years, 2600. Let's see. 3600. Oh, wait, it would reach 3600. Let's try 3 years. 3 years should be, let me make a guess before I run it. 3 years is going to be coming in around 1,000. Let's try 3 years. So let's put in 3 years here. And yeah, perfect. Okay, we got it. So it's good. It's good. So I'm happy. I'm happy. And I like that we got to, have a student suggest a good, interesting project like exponential growth. And then I threw something out there just thinking about how bunnies reproduce, reading about, how many litters they give. And then the population growth was just insane, right? Like the numbers were getting so crazy. So I said, well, let's look it up and find like some mathematician who's modeled this. And we found a nice looking textbook. This is probably the type of textbook you would have in a middle or high school, probably high school. This isn't really middle school. And then they give us a nice formula that we just turned into Java. And what's kind of cool is we can see that they give other ones about interest and geometric sequences, and it's kind of fun. So, like, I'm glad that we had that suggestion, and it's only 741. It's not like we spent, the entire class on it, but it's good. So the other suggestion was make a class so we can put the method inside, which is great. So here we have our class from line 1 through line 18. And if you ever wanted to fork this, here you can see the replit link. You can always fork these. You can always fork the code. And fork just means you click on the little button, and then you can change it to whatever you want on your replit, right? So your REPL can change it. Okay, so let's think of something that you guys can do. So there was another student who mentioned square root a little while ago. So why don't we do that? So ask the user to read in a number. Oh, I know, this will be good. Ask the user to keep reading in positive numbers. As soon as the number is negative, stop reading in. Stop. Okay? For each number, and we'll assume like that they're going to be doubles. For each double number, provide the square root of the number. Okay, for each positive number, not that you can't give the square root of a negative number, but it's just, for this example, we're only going to be reading in positive numbers, just to give it a little twist, do some fun coding this morning. Okay? Now, last class, what I was doing was, I was just like, I guess you could say calling on people. I was saying, Well, how's progress? What have you done? And I think I mentioned this last time, just crickets, no response, just not communicative. Okay? Let's see. Christian says, I don't know if it's too difficult, but I was thinking to calculate compound interest. So we can do that example too. We can do both of those for sure. But since I already typed all this out, just so I'm not like going back on it, let's just go ahead and do this example, right? Let's all do this example. And I really would like for you to um, send me what you're doing. Like if I just message you and say, oh, how's it going? Just say, oh, this is where I'm at now, and you just send the code, right? That just shows me that you're engaged. Because, you know, I I wouldn't like to just be speaking to only a few people now. I need people to be actually doing these things, and that's how you're going to keep improving, by just practicing, practicing, practicing. So let's all try this. You're going to need a loop, right? You will need a loop to do this. You will need a scanner to do this. You will need the square root function, and that's one of the big things we're talking about today. Um, you will need a method, right? I'd like you to put this inside of a method so you can just call it. You can make it static, that's fine. And then you'll need a print statement. You'll need print statement. So I'm going to stop talking, get to work on this, and then we'll be in touch. our solutions here. Now, I got some good messages, and I did ask a student, Frank, are you there? I can't. Can anyone else hear Frank? Yeah, just check your input device. Oh, maybe I'm muting him. Let's see. No, there's no server mute. Let me unmute everybody. All right, let's see.
Hello.
There we go. Nice. All right, can you share your screen? Right, yeah, because we're going to have a student share their screen.
Hello.
Hi, we can hear you now.
All right.
Can you share your screen?
How do I do that?
You see the little button that says screen next to video on Discord? Okay, so now it's muted.
Yeah.
Yeah, just click that. There we go. Now I'm going to mute, and you just explain what you did.
Um. I just did. Well. No, it started off with well, I was just trying to figure out how I was gonna display it, and I just I just ended up deciding on putting it on array list, which yeah, I just did the. He said I needed a loop, so I just did the loop, and then yeah, and then but I kept putting in the negative, so then I just changed it to only accept the positive parts. And well, I don't know what else to say.
Let's see. So how come you decided to use an array list?
I just thought it would look neater. I don't know, and that was just the first thing that came to mind.
Great. Well, looks super good. You can just copy and paste that code and then put it into Discord, and then now we'll all be able to look at it. All right, great. So you can go ahead and end your screen sharing, and thank you for explaining that. And we can all stop watching now. Okay, great. So now let me go back and share my screen. And okay. So there were other suggestions today about like things that we can code, and I enjoy coding things in front of you. Like I enjoy live coding. I think I like talking through like what I'm doing, but you know, it's not all about what I enjoy doing, because just because something's fun for me, like, you know, starting at 7 in the morning until 8:40, you just watching me code, that would be fun. Like I would like teaching a class like that, but I really don't think that's in your best interest just to keep watching me coding, coding, coding. And besides, there are lots and lots of videos of people doing live coding of like all different levels. Like there are beginners who do live coding. There are the most advanced programmers in the world practically who do live coding. It's it's like all out there, right? You can just sit and watch hours and hours of footage on YouTube, and it's okay. It's not bad, right? Like if I thought it was a really bad thing to watch me code, I wouldn't do it. But I think it has value. But there's value in lots of different techniques, right? One of the things is just reading other people's code. So reading other code is valuable. Okay? Going on Memer and solving problems that are listed out is valuable, because you have to sit there and you have to think through, okay, we've got this object oriented assignment, we've got this IDE scavenger hunt. Nothing is new, right? I didn't open up anything new on Memer right now. So it's still the same object oriented first assignment, letter writing assignment. Excuse me, IDE scavenger hunt. So that has value, right? And Code Wars has value. You go on Code Wars, you solve problems, that has value. So reading the textbook, reading the code, all of these different things have value. But I think also working with each other has good value. So do you see now the list of groups? Does everyone see that they're now associated with a group? Do you see if you have a group visible? You should see like a group 1 and a group 2. Well, just look here in Discord. Do you see like a group 1, group 2, group 3? Okay, perfect, perfect. Good, good, good. So here's what we're going to do. We are going to, with our groups, solve a fun little problem. Now, have we done this problem together? Let's first look at this one. Have we done this problem together? Multiples of 3 or 5. Have I done this in front of you? Like, or for you? You did, okay. I thought we might have. So, then let's pick a different one. So, let's pick this one. Have we done this one in class? Even Fibonacci numbers. Each new term of the Fibonacci sequence is generated by adding the previous two terms. Okay, perfect. Good, good. So this is what we'll do today. Now, we definitely have a time crunch, right? You and your group members are going to try to get this done before 8:40. The goal is to finish before 8:40. Okay? So you have a voice chat, so you can talk. So ladies and gentlemen can talk in the voice chat. Voice chat is fine. Text is fine. And group members can share their screen. And this is going to be a really, really good exercise. So we will use the groups during the class, right? Okay, so it won't just be for this one exercise. We're going to use it for lots of different exercises. Okay, so introduce yourselves and try to solve this problem, and try to get it back to me within the next 16 minutes. Okay, because then class will be over. So good luck. So leave this main chat and go to your, everybody go to your groups now.